Hey everybody, this is Mr. Schultz here with you, and we're going to be taking a look at 9.4.1, and this is going to be day one, and it's going to be about real numbers, which just in and of itself sounds very funny, but it sounds less funny than if you think about what the contrast that is, which would be imaginary numbers. And guess what? There are such things as imaginary numbers, and they're generally done by the symbol I. So now that makes real numbers feel less crazy. So let's take a look at real numbers. So any number that can be written as the ratio of two integers, a divided by b, where b is not equal to 0, is called a rational number. So if it's rational, it just can be written as a fraction, where b is not equal to 0. So fraction where the denominator is not 0. A rational number can be matched exactly at one point on a number line. There are many other points on the number line, however, for which the corresponding rational for which there is not a corresponding rational number. These numbers are called irrational numbers. They are numbers such as pi, that's a very famous one, the square root of 2, negative square root of 5 are irrational, which basically just means they're numbers that just go on and on and on and on and on. So in this lesson here, I'm going to skip ahead. We're just going to learn how to identify a number as rational or irrational. So let's take a look at what this looks like. Okay, so on this one here, which is going to be question 9-50. So on question 9-50, we're going to decide if things are rational or irrational, and we're going to do it with a calculator. So let's see what this looks like here. So I want you to type into your calculator square root of 6.25. So if you're going to use your phone as a calculator, make sure that you're using a scientific one so you can get this square root function. If you're using decimals, also great. And then write down what, and then basically here what we're looking for is this: is a number rational or is it irrational? Which basically the difference here is that if it's a rational, it's a terminating or ending and not repeating decimal. If it's irrational, you're looking for something that does not have a pattern. So what I want you to do is type in these three numbers in your calculator, decide if they're rational or irrational, and then I'll show you in just a second here. All right, so on our first one, which is the square root of 6.25, when I plug that into decimals here, I see that it's the decimal 2.5. Well, 2.5 ends, so if the number ends, then it is rational. So this one here is rational. Our next one, the square root of 100, that's a perfect square, so it lands at a nice and whole number of 10. So again, that's a terminating or ending decimal, so it is rational. My last one, the square root of 7. See, it just goes on with these weird numbers here, 6, 4, 5, 7, 5, 1, 3, 1, 1. There just isn't a pattern here on the square root of 7. So this is what's called an irrational number, meaning that it just keeps going on and on and on. It doesn't end. It doesn't repeat. So let's take a look at this with our next problem. All right, so moving on to the next problem, which is 9-51. Do you think you can decide by looking at a number whether it is rational or irrational? So here's what we're going to do first. In part A, I want you to look at these 8 numbers and just make a prediction. Do you think it is rational? Do you think it is irrational? Do you think it's rational? Do you think it's irrational? And so on and so forth. And then after we do that, then I'm going to have you plug them all into your calculator and see which one is rational, which one is irrational, based off that kind of repeating or ending or not repeating, not ending decimal. So first, make a prediction on each of these numbers. Decide if it's rational or irrational. And then after that, go back through and check them out and see if they are. And remember, here is the summary of things that make rational. So if it is rational, it can be written as a fraction. If it's rational, it's a decimal that ends or terminates. If it is rational, it's a decimal that repeats. Those are kind of your 3 most common things that make a rational number. If it is an irrational number, the biggest thing is this: it doesn't end. Or let's see here. It's not a fraction, so it's basically just all of the inverses here. So it's not fractions. It does not end, and it does not repeat. Okay, so using this information, take a look at these 8 numbers, decide are they rational or irrational. And you can pause the video, and we'll go through them in just a second. All right, so here we are. So looking at these here, the first one, you should have got rational. That is a fraction, so therefore it has to be a rational number. This one is irrational. We did this on the last page, but it is a square root of 7. We can see in the calculator it just keeps going on and on and on. It doesn't stop. So then here, 21 over 4, that's again a fraction, so it's rational. Negative square root of 15, this is irrational, because again, it just keeps going on and on and on without a pattern. Then after that, I've got this pi squared, so just pi times by pi. Well, pi squared, again, I don't see any sort of a pattern happening here in the decimal. Same thing with negative square root of 76. So these last three, negative 15, pi squared, and negative square root of 76 are all irrational numbers. They just keep going on and on and on. They do not repeat. On this one, this is a fraction, so it has to be rational. And our last one, this is just a decimal. So negative 6.4 times by 10 to the negative second is a decimal that ends. So we can see that it stops right there. Therefore, it is a rational number. So here is your kind of big takeaway here in Part C. Part C says, what do you notice about the decimal forms of rational numbers compared to irrational numbers? So basically, if it is a decimal, it's just like what I said before. If it's a decimal that is rational, then it should end or terminate, or it should repeat. So if it ends, or if it ends or terminates, or if it repeats, so like 0.3333, and so on and so forth, then you've got a rational number. Now you might have also noticed that, hey, a bunch of our, or most of our irrational numbers were these square root ones, and then pi. But let's take a look at this one. Square root of 42.25, is it rational or irrational? Well, based off what I just said, you're probably thinking now, well, that's a trick question, it's rational, but why is it rational? So if you look at this, if you plug this into your calculator, and you've got the square root of 42.25, that is equal to 6.5. Well, 6.5, you can that is definitely a decimal that ends. So just be careful with your square roots. Most of these are irrational. But some of them are not. Some are rational. So just be careful when you're doing these. I think the best way to approach this is just plug in your calculator and look for something that is creating some sort of either a decimal that ends or a decimal that repeats. Let's take a look at the next problem. So in question 9-52, it says, every rational number can be written as a fraction, which is what we talked about last time, and that's how we justified a lot of those. So that is a ratio of two integers, aka a fraction is kind of the more common term that you're used to hearing. And since 0.78 is described in words as 78 hundredths, that's why we would write the equivalent fraction as 78 over 100, because it's 78 hundredths, so 78 out of 100. So here's what I want you to do. Write out these fractions write out these decimals in fractional form. So if you do the first one here, well, this would be 19 hundredths because it's in the hundredths place, so I just write it as 19 over 100. If I was going to take a look at the next one, this is 391 thousandths, so I'm just going to do 391 over 1,000, and then we can see that it is a fraction once again. So why don't you work on the rest of these, and I'll show you the answers here in just a second. So pause the video and see what you can come up with. All right, so here are the rest of your solutions. So 1 1,000th, 19 over 1,000, 3 over 10, and 524 over 1,000. Let's take a look at our last problem here. So 9-53 says, Jessica knows that the number 0.57 in the 57 is repeating is a rational number. So she should be able to write it as a fraction. She wonders how to rewrite it though. She started to rewrite it as 57 over 100, but she's not sure if that is correct. Is 57 over 100 equal to 0.57 repeating? Justify your answer. Well, if we think about what 57 over 100 is, we should be able to write that as a decimal, just like we did, but we went backwards. It should be 0.57. So really the question is 0.57, is that the same thing as 0.57 repeating? Are these the same thing? And what the answer is here is no, because what this is equal to is 0.575757. It keeps going on, whereas this one just stops. There's nothing else here. So how do I keep going on and writing this as a fraction? Well, that's what we're going to look at tomorrow, is how do you write numbers like 0.57. Repeating, how do you write that as a fraction? If you want to cheat it and look ahead, or not even cheat, you can plug this in to Desmos and see what you come up with. Because Desmos will be able to write this as a fraction, as would most calculators. So you can certainly go and look at that, but we'll take a look at it more when we look at 9.1.4 day 2. We'll be looking at day 2 tomorrow. That's everything that I've got for you today. One last slide here, just kind of summarizing stuff here. So real numbers include all rational and irrational. So really what this means to you is real numbers are your most common. These are basically any number. And most time we use just rationals, but every once in a while we might dip into some irrationals that don't end. So rational numbers, the biggest and simplest way is if it can be written as a fraction, it's a rational number. But the bottom part, the denominator, cannot be equal to 0 because otherwise that's not a number. It does not exist. So here's a bunch of examples of rationals. Like, for example, another one here, the square root of 25. That's rational because it's the number 5. Well, 5 can be written as 5 over 1, and so on and so forth. Irrationals are just the opposite of that. They're any number that cannot be written as a fraction. They're also decimals that do not terminate or repeat. So, for example, the square root of 3. So square roots are very common irrational numbers, and then there's a very famous one here, pi, that you've probably seen before, especially in 7th grade with 3.14. So that's it. Have a good rest of your day. Bye-bye.